Now we are heading towards 3D shapes. First, cuboid. So cuboid is a solid bounded by 6 rectangular planes. Rectangular plane regions. So this is bounded by 6 rectangular plane regions. So we'll draw the figure first. So this is cuboid, and we'll name the points here A, B, C, D, E, F, H and G. So this is cuboid. This is how it will look geometrically. Now we'll see properties or concepts related to that. The first is faces. So this cuboid is made up of 6 rectangular faces, or 6 rectangular plane regions. We'll draw one by one, or we'll paint one by one. So this is first. So this face is A, B, E, and F. Then this one, this face is A, B, C, D. Then this one, this face is A, D, G, E. Now the bottom face, it will overlap the colors, but we'll do somehow. So this is E, F, G, H. This one, E, F, G, H. Then this side, this face. So this comes as B, C, H, F, and the back side now. And this is this one. So it is C, D, G, H. So these are 6 faces or plane regions, and these plane regions are the faces of cuboid. So let's see this. Let's see A, B. I just drawn a front face A, B, E, F. This is a rectangular plane region out of these, and this is one of the face of the cuboid. Now the edges. So what are edges? Any two adjacent faces of cuboid meet in a line. They meet in a line segment, and it is called edge of the cuboid. So let's see, we'll draw our cuboid once again. A, B, C, D, E, F, G, H. I just the name to the points, I just made an alternate order for this figure, because here EF was in front, here FG is in front. So in this edge, we are looking at the edge. So this is AB, this is the edge of which faces? The face A, B, C, D and face A, B, F, G. Both faces meet at a line segment, or they form a common line segment. This is edge of these two faces. So here AB, line segment AB is an edge. Like that, line segment AD is an edge, this one. And here it is formed by A, B, C, D face 1 and A, D, E, F other face. So formed by these two line faces the common line segment, that is AD. Then accordingly there is a line segment BC, and it goes on. So there are almost 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12 edges are there in total. I just written 3 of them right here, right now. Then vertex, we'll write down for any two edges that meet at an end point, there is a third edge. There is a third edge that also meet there. So meets them at end point. So the point of intersection of 3 edges of a cuboid is called a vertex of the cuboid. So we'll draw the cuboid again and we'll see the vertex. So this is our A, B, C, D, E, F, G and H. And let's see this edge. So if we consider edge AD, so what is saying, for any two edges that meet at an end point, let's see any two edges. So AD and this AE, AD and AE, we can say that they are meeting at endpoint A. There is a third edge, any two edges that meet at an endpoint, there is a third edge that also meets them at that endpoint. So here it is, that third edge, BA or AB. If we want to say A as an endpoint, we must say BA. So DA is an edge, then EA as an edge, and BA as an edge, and they are meeting. All meeting are there at the endpoint A, and A is the vertex, and based on that there are vertices of this cuboid are A, B, C, D, E, F, G, and H. We have given the names to name as an word to that points. Then comes solid cube. What do you mean by solid cube in terms of geometry? A solid cube or a cuboid or a cuboidal region in the part of space bounded by 6 faces of cuboid. So cuboidal region means it's part of the space bounded by 6 faces of cuboid. So if we draw a cuboid like this, so part of the space, this is what whole space, that is our canvas right now, and it is bounded by this cuboid is the space inside that cuboid. This part of the space is represented a solid cube or a cuboid or cuboidal region, we must say. So this region is a cuboidal region. So why to specify such things? Because when the problem statements comes, they ask that given as cuboidal region. So what do you mean by cuboidal region? You should understand it is bounded space by that cuboid. So the space, it is represented by the cuboidal region. When we represent something, we can act on it and we can process on it. Then comes what is known as cube. A cuboid whose length breadth and height all are equal is known as cube. So we'll try to draw the cube. So this is cube, and we consider that its length means its length, breadth, and height of are all are equal. So this and this all are equal. This is a cuboid having length, breadth, and height all are equal is a cube.